Yo, Code Pilots! Welcome to Part 4 of the Python OOP Masterclass. We've covered properties, and now we're diving deep into inheritance. This will be detailed, so hit that like button and let's get started. Let's begin with what inheritance is. Inheritance is a core concept in OOP where a child class can inherit attributes and methods from a parent class. Think of it like a family tree. A car can inherit from a vehicle class. Reusing code and building on it. This reduces redundancy and sets up a hierarchy, and we'll explore this with car examples. First, let's create a vehicle parent class. Define it with def init self speed to set self.speed, and add a method def move to print vehicle is moving. This will be the base class for our car-related examples. Let's set it up and move forward. Let's test the vehicle class. Create myVehicle equals vehicle 60 and run myVehicle move to see the output. This gives us a starting point. Take a moment to observe the result and understand the parent class's role. Now let's create a car child class that inherits from vehicle. Use class car vehicle and add def init self speed brand to set self brand while calling the parent's init with super init speed. This links the child to the parent. Let's add it and test next. Test the car inheritance. Create my car equals car 100 Toyota. Run my car move to use the inherited method and print my car speed to check the inherited attribute. Take time to see how the child class builds on the parent. Discuss the output. Let's add a specific method to car. Define def honk self to print beep beep from self brand. This adds unique behavior to the child class. Let's include it and prepare to test. Test the honk method. With my car equals car 100 Toyota, run mycar.honk to hear the car's sound. This shows how the child can extend the parent. Pause to explore this new feature. Let's create another child class, sports car, inheriting from car. Use class sports car car. With def init self speed brand top speed to set self.topspeed, calling super init speed brand. This creates a multi-level inheritance. Let's add it. Test the sports car class. Create my sports car equals sports car 200 Ferrari 300 and run mysportscar.move for the inherited move. Print mysportscar.speed for the car speed and print mysportscar.topspeed for the new attribute. Take time to see the hierarchy. Let's override the move method in sports car. Define def move to print sports car print is racing at self speed kilometers per hour. Update the class. Let's include it and test next. Test the overridden move in sports car. With my sports car equals sports car 200 Ferrari 300, run mysportscar.move to see the racing message. This shows how a grandchild can customize behavior. Discuss the output. Let's add a practical example with a garage class. Use def init self to hold a list of vehicles and def add vehicle to add any vehicle object. Add some car and sports car instances. Let's set this up. Test the garage class. Create garage equals garage. Add my car and my sports car with garage.addVehicle, my car, and garage.addVehicle, my sports car. Then print the list. This shows inheritance in a real-world context. Take time to explore. Let's enhance garage with a display all method. Define it to loop through vehicles and call move on each. Update the class. Let's add it and test. Test the display all method. Run garage display all to see all vehicles move. This demonstrates how inheritance allows a uniform interface. Pause to analyze the result. Let's add a speed check to display all. Modify it to print only vehicles with speed greater than 100. Update and test. Discuss how inheritance supports this filtering. That's a wrap for Part 4. Code pilots, you've mastered inheritance with car examples. Like this, subscribe, and try your own inheritance trees. See you in Part 5. Keep coding.